Hello friends, I am Shaikh from Electrical Engineering Department of AISSMS Institute of Information Technology. Welcome to the second part of the breakdown theories in commercial liquids for high voltage engineering subject. In the previous video, we have already seen the suspended particle mechanism or theory for the commercial liquid. In continuation with that, in this video we shall cover the cavitation and bubble mechanism. As per the cavitation and bubble mechanism or theory, the processes responsible for the formation of vapor bubbles are gas pockets at the surface of the electrodes, electrostatic repulsive forces between space charges which may be sufficient to overcome the surface tension, gaseous products due to the dissociation of liquid molecules by electron collision, and vaporization of the liquid by corona type discharge from sharp points and irregularities on the electrode surfaces. Now, it was experimentally observed that in many liquids the breakdown strength depends upon the applied hydrostatic pressure, suggesting that a change of phase of the medium is involved in the breakdown processes, which in other words means that a kind of vapor bubble formed is responsible for the breakdown. Now, once a bubble is formed, it will elongate in the direction of the electric field under the influence of the electrostatic forces. Here is a schematic representation of a test cell showing that there are two electrodes and the test cell is filled with a liquid insulating material. One electrode is connected to the high voltage source and the other electrode is grounded. A high voltage is continuously applied to this electrode which has a fixed gap distance. Now, due to any of the reasons stated earlier, if there is a bubble formed in this particular liquid, then on application of high voltage, the bubble will start elongating in the direction of the electric field. So it will come first of all under the influence of the electric field and then start elongating in the direction of the electric field. The volume of the bubble remains constant during the elongation. However, when the breakdown will occur when the voltage drop across the length of the bubble equals to the minimum value on the Paschen's curve. This breakdown field is given by this equation over here. In this equation, sigma is the surface tension of the liquid, epsilon 1 is the permittivity of the liquid, and epsilon 2 is the permittivity of the gas bubble. R is the initial radius of the bubble assumed as a sphere, and Vb is the voltage drop in the bubble corresponding to the minimum on the Paschen's curve. From this equation, it can be seen that the breakdown strength depends on the initial size of the bubble, which in turn is influenced by the hydrostatic pressure and temperature of the liquid. The only drawback of the theory is that it does not take into account the production of the initial bubble, and hence the results given by this theory do not agree well with the experimental results. Hope you have understood this theory well. Thank you.